Computer Vision, How AI Sees the World, Hook Context. Welcome back to AI Fundamentals Explained. In our last episode, we uncovered how large language models like ChatGPT actually work, revealing the transformer architecture that powers the AI revolution. But while language models process words, there's another form of AI that's quietly reshaping our visual world. Today, we're diving deep into computer vision, the technology that gives machines the power of sight. By the end of this video, you'll understand how AI systems recognize faces, detect objects, power self-driving cars, and even diagnose diseases from medical scans. More importantly, you'll see why computer vision might be the most impactful AI technology of our time. Section 1. The Pixel Foundation. Let's start with something fundamental that most people get wrong. When you look at this image, you see a face, a landscape, or an object. But when an AI looks at the same image, it sees something completely different, a massive grid of numbers. Early computer vision systems tried to work with these pixels directly, looking for edges, corners, and basic shapes. But this approach hit a wall. Real-world images are messy, noisy, and infinitely complex. A cat photographed in different lighting, from different angles, or even just slightly out of focus, would completely fool these early systems. Section 2. The CNN Revolution. Everything changed with convolutional neural networks, or CNNs. Think of a CNN like a detective that examines an image through multiple magnifying glasses, each one looking for different clues. The first layer of a CNN acts like an edge detector, scanning across the entire image looking for lines, curves, and boundaries. It's not looking for specific objects yet, just basic visual building blocks. The second layer takes these edges and starts combining them into more complex patterns, maybe corners or simple shapes. As we go deeper into the network, something remarkable happens. The third and fourth layers start recognizing textures, patterns, and object parts. We might see detectors that specifically respond to fur or eyes or wheel-like shapes. The deepest layers combine all this information to recognize complete objects, scenes, and even abstract concepts. Section 3. Training AI to see. But how do we train these networks to see? The breakthrough came with massive labeled datasets. ImageNet, created in 2009, contained over 14 million images, each carefully labeled by humans. This gave AI systems millions of examples to learn from. During training, the CNN makes thousands of predictions, most of them wrong at first. It might look at a picture of a golden retriever and guess cat or even banana. But here's the key. After each wrong guess, the network adjusts its internal parameters slightly. Multiply this process by millions of images and thousands of adjustment cycles, and something extraordinary emerges. By 2012, CNNs achieved a breakthrough that stunned the computer vision community. The AlexNet architecture didn't just win the ImageNet competition, it crushed the previous best results. For the first time, AI could recognize objects in photographs with near-human accuracy. And this was just the beginning. Section 4. Beyond recognition, object detection and segmentation. Recognizing what's in an image is impressive, but modern computer vision goes much further. Object detection systems can identify multiple objects in a single image, drawing precise bounding boxes around each one and labeling them in real time. Even more advanced is semantic segmentation, where AI systems can identify the exact pixels that belong to each object. Instead of just saying, "There's a person in this image," the system can outline the precise boundary of that person, distinguishing them from the background pixel by pixel. Instant segmentation takes this one step further, not only identifying object types but distinguishing between individual instances. In a crowd scene, it doesn't just recognize people, it separately identifies person number 1, person number 2, and so on. Section 5. Real-world applications. Let's talk about self-driving cars, perhaps the most ambitious application of computer vision ever attempted. Every Tesla on the road is essentially a computer vision laboratory on wheels, using 8 cameras to create a 360-degree view of the world. But here's what's truly remarkable. The AI doesn't just see cars and pedestrians. It understands context, predicts behavior, and makes complex decisions. It recognizes that a ball rolling into the street might be followed by a child. It notices when a driver in an adjacent lane is texting and might drift. It reads construction signs and adjusts its route accordingly. In healthcare, computer vision is literally saving lives. AI systems can now detect certain types of cancer in medical images more accurately than human radiologists. Google's AI can identify diabetic retinopathy from eye photographs, potentially preventing blindness in millions of people worldwide. In manufacturing, computer vision systems inspect thousands of products per minute, identifying defects too small or subtle for human eyes to catch. In agriculture, drones equipped with computer vision can monitor crop health across vast fields, identifying disease or pest problems before they become widespread. Even retail is being transformed. Amazon Go stores use computer vision to track what customers pick up and put down, enabling checkout-free shopping. Virtual try-on technologies let you see how clothes or makeup will look without physically trying them on. Section 6. The challenges and limitations. But computer vision isn't perfect. These systems can be fooled by adversarial examples. Images that look normal to humans but cause AI to make wildly incorrect classifications. They struggle with edge cases and can exhibit harmful biases, particularly in facial recognition systems. There are also growing concerns about privacy and surveillance. The same technology that helps your phone organize photos is also being used for mass surveillance in some parts of the world. As computer vision becomes more powerful and ubiquitous, we'll need to carefully consider how we want this technology to be used. Conclusion. Word count: 1,650 words. Estimated duration: 11 minutes avatar segments, 3, hook, bump, conclusion. Scene markers: 24 shorts, candidates, 3, mythbuster, micro tutorial, teaser.